Okay. We are in new chapter, chapter 5. And chapter 5 goes into um, rational numbers and solving rational equations. Today, in this section 5.1, we're going to be talking about rational numbers. Before we get into rational numbers itself, let's take a look at some other definitions for values. For the first two that you have up on the screen are whole numbers and integers. Whole numbers are like counting numbers. So you got 0, 1, 2, 3, dot, 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 all the way until infinity. Integers are whole numbers, but they also include the negative values of those whole numbers, like -1, -2, -3, and so on, all the way up to negative infinity, and also to positive infinity. So we tell you this because rational numbers is a number that if you take a divided by b, where a and b are integers, so there's something that fits this category, and b does not equal 0. The reason why b cannot equal 0 is because if you were to say punch this into your calculator, you would get an error code, and dividing anything by 0 is considered undefined. Examples of rational numbers are like -1/2, 3/4, or 5/1. A example of a non-rational number would be something like the square root of 2 over 3, okay? Because this is not an integer, okay? First thing that we're going to talk about is to be able to identify rational numbers, either if they're in integer form or in mixed numbered form. If you look at the big value that we have up on the screen, I have 4 and 4/5. Okay, that is an example of a mixed number. Okay, in order for it to show that it's an rational number, we have to make it into an improper fraction. And here's what you do. If it's a mixed number and we want to turn it into an improper fraction, we do this. First, we're going to take these two values and multiply them together. So 4 times 5 is 20. Then this value of 20 gets added to the numerator. So 20 plus 4 is 24. And that gets placed as my numerator of my rational number, and my denominator is exactly the same as it was in the mixed number. Okay? So in these examples, I want to be able to write this as the quotient of two integers. Quotient means division. So if I just have 22, well, all I have to do is write 22 divided by 1 because it satisfies all the terms in the directions. I got the quotient with the division, which is my division sign, which is my fraction bar, and I have two integers, one in the numerator and one in the denominator. If I look at b, same premise. So I can say -15 over 1. Okay? For C and D, we have to use the steps to make a mixed number into an improper fraction. So 10 times 2 is 20. 20 plus 1 is 21 over 2. Okay? Looking at D, here's something that is very important, especially when it comes to using negative mixed numbers. You do not pay attention to the negative number until the very end. So I'm just going to put that negative number at the end. It doesn't matter if it's negative or positive when it comes to the multiplication and adding of our values, okay? Because it could be easily mistaken for taking -8 times 3, which would be -24, adding it to 1. Well, -24 plus 1 is actually -23. But you do not use the negative number when you're making an improper fraction. So you're just going to say 8 times 3, which is 24. 24 plus 1 is 25. And then you just attach the negative onto the improper fraction. Okay? Another thing we get to do is we are going to be able to write fractions as decimals. Now, when we're dealing with rational numbers, they can be either be a terminating decimal, which the decimal has an end, or it's a repeating decimal, and it repeats a digit or a block of digits. And I'll explain what that looks like. So I got two examples here. I got 2 and 7/11ths, and I got 5/8ths. So if I look at 2 and 7/11ths, what I'm going to do is all I'm going to concentrate on is that 7/11. So I'm going to use my fraction bar. I got 7 divided by 11. Right now, there's no value of 11 that goes into 7. So here I'm going to put my decimal point here, put my decimal point here, and make it 0. So it looks like 70. So how many times can 11 go into 70, which is 6? And 6 times 11, which is 66. And that would give me 4. So since I have a remainder, I'm going to put another 0, bring it down. And now I'm going to look at how many times can I get 11 into 40. That's just 3. And that becomes 33. This is a difference of 7. Bring this down. I got 70 again. It looks like it'd be another 6. This is 66. 4, 0, 4. And it would be 3. So now I'm seeing a pattern. Okay? The pattern is 6363. So when I write it as a decimal, again, I'm going to bring back my 2. So it's going to be 2.63 repeating. All right. That little bar on the top of my 2 decimal values tells people that those 2 numbers keep repeating on and on until infinity. Okay? You only put the fraction bar, or that little horizontal bar, I'm sorry, when there is a repeating value. Okay? If you look at 8 over 5, so I'm going to put 8, or 5 divided by 8, I notice that there's no value of 8 that goes into 5, so again, I'm going to do my decimal point, put a 0 here, and it goes in 6 times, so it's going to be 48. The difference is 2, so that means I put another 0, which makes it 20. 8 goes in 22 times, so I got 16. I got 4, another 0. 8 goes into 45 times, and the difference is 0. So I have a 0 remainder. So the decimal equivalence of 5/8 is 0.625. So the first example, 2 and 7/11ths, is an example of a repeating decimal. 5/8 is an example of a terminating decimal. So if we do some more, again, we're going to take, put 20 here, put it 13 inside the fraction bar. Can't put anything there, so put 0 here. And 20 goes into 136 times, which makes it 120. So that makes it 10 here. Drop it down, makes it 100. And 20 goes in 105 times, makes it 100, which is my remainder of 0. So the value, the decimal equivalence of 1320 is just 0.65. And 1 and 7/12ths, if you look at, so I'm not going to worry about the 1, so I put 12 here, I put 7 here, put my decimal point, and what value How many times does 12 go into 70? Well, the answer is 5. And 5 times 12 is 60, which leaves me with a remainder of 10, so drop down to 0. And that would be 8. That gives me 96. This gives me 4. Drop down to 0. 12 goes into 43 times, so that's 36. This gives me 4. And looks like I'm going to find a pattern of 3s. So this, as a decimal, is going to be 1.583 repeating. You only put the repeating bar on top of the 3 because the 3 is the only thing that repeats. The 5 and 8 do not. Another thing we're going to talk about is being able to write decimals as fractions. And again, this is a little tutorial, quick tutorial of what the digits are. Like this is my ones digit, this is my tens, this is my hundreds, and this is my thousands. To write a terminating decimal as a fraction, use the place of the last digit as the denominator. Okay? So if I look at 1.6, I'm going to do this. I'm going to say 1, and then I have a 6 here, and it is to the tenths, it's 6/10, so that means that I put a 10 in the denominator. So the only thing I have to do now is put 6/10 in lowest terms. So if you divide both the numerator and denominator by 2, it's going to be 1 3/5. Looking at B, I got -9, and I'm going to put 42 over 100, which means that if I reduce -9 into lowest terms, it's going to be 21 over 50. Another thing that would be helpful to look at is how you can make repeating decimals fractions. So like say if I have something like 0.2 repeating, okay? So if you have a repeating decimal, and right now you just have a single digit that's repeating, you're going to be able to go, the value of this is going to be 2, and you're going to be able to divide this by 9. So 2 divided by 9 would be 0.22222 if you check it on your calculator. If you had something like 0.23 repeating, you would then go 23 divided by 99. Okay? It's just how many digits that you're given to repeat will show, will be able to determine your fractional equivalence of the decimal. Last thing we're going to talk about is ordering of rational numbers. And for this example, we're going to want to write these from least to greatest. If you look at the little bar here, we either want to write the we can write them as fractions or as decimals. I like to use decimals because they're easier to see. So what I'm going to do is make each fraction into a decimal. So if I look at 9/4, that is going to be a decimal of 2.25. If I look at -9/8, I'm going to have a -1.125. And 13/7 is going to be very close to 1.85714. And that will keep going. But for this sake, we'll be able to decipher which ones are from least to greatest. So the least value one is, first of all, I have to do is take a look at the negative numbers. I have two of them. I have a -0.9 and I have a -9/8. Well, if I look, 9 over 8 is negative 1.125, and this is just a negative 0.9. So this value is my least, my smallest value, my greatest negative number. So that gets crossed out. And then my next negative number is negative 0.9. Make sure that you rewrite them in its original state. Don't use the fractional equivalents that you've given each fraction, but write them back in its original state. Now that we're done with the negatives, let's take a look at the positive. I have one that's got a 0 in the 1 spot, so that's my next smallest term. From here, I got a value of 1, 2, and 2, so 13/7 is next. And then I got 2.25 and 2.7. Well, 7 is larger than 2, so I guess the next one's going to be 9/4. And then to finish it up, the largest number is 2.7. And there you go. And that is being able to use irrational numbers. Hope this helps. Until next time.